discussed about the loading strategies in data warehousing, right? So, and we have seen examples of different loading strategies: full load, incremental merge, incremental append, right? So, different examples we have seen, and I hope we understood uh, what are different loading strategies that we have, right? So today we will go a little bit deeper into data warehousing, right? We will try to understand what actually is the data model, and what are different types of data models, right? So what is star schema, what is snowflake schema, and then we'll see what is fact table, what is dimension table, right? So we will see what are measures, we'll see what are dimensions, right? So today's discussion is very important to understand, little bit deeper, and deeper things in data warehousing. Okay, so I think everybody joined. Okay, so let us start our today's session. Let me start my screen quickly. Okay, so yesterday we have seen what is incremental merge, what is actually incremental append. So how we will do, incremental load using watermark table. We have seen different examples, right? So today we will try to understand how actually a data warehouse will be, will be built, right? So in a OLAP system, right? So in a typical data warehousing, so let us assume I have a data warehouse system, and I have different tables, right? I have different tables in this data warehouse. Okay, so now when we are storing this data, right, not only in data warehouse, it may be in OLTP also. So when we are storing in this data in this data warehouse, data redundancy is a biggest problem. Okay, so data redundancy is a biggest problem. Meaning, so let's see an example. The duplication of data, redundancy meaning duplication of data. So let us take an example. I have a table. Let me take the Excel. Okay, so ID, or let us take sales or customers model, right? So here, if you see, I want to store the entire information of a store or a retail store into a table, right? So let's try to prepare the data for it. Okay, let's try to prepare the data for it. So I have the customer, and then uh, product name, and then product quantity, rate per item, price, total price, customer email, customer location. Okay. Yeah. So assume this is my table, right? So when if we consider one simple retail model or retail data, right? So you have customer name and then product name, product quantity, rate per item. I mean, for example, rate per kg if it is, or item category, we can say item name, and then we can say item category, item per item price, right? See here, what will be in a retail store, if we go and observe, right, we will be having products, correct? So we'll be having n number of products, and we'll be buying those products, and the transactions will be happening, right? So now assume if you are keeping entire transaction data in one table, okay, if you are keeping entire transaction data in one table, what will happen? For example, if I buy 100 products, right? So now assume I'll be having 100 records here in place of customer. Let us say I'm a customer, okay? So I brought 100 products, okay? I brought 100 products. So if I maintain a single table, my customer name will be duplicated, is it right? And then customer location will be duplicated, right? And then let us assume I have bought same items from the same category, right? So in that case, my item category and item name will be item price will be repeated, right? And the product name, so let us take an example. I have brought same product, you know and then from the different category, same products from different item categories. So in that case, this will be duplicated. So if you just understand the customer details so that you will get more clarity, and the location information, right? So assume as a customer you went and you brought 100 different products, okay? As a customer you went and you brought 100 different products. Now what will happen? Your customer details will be duplicated in this table, right? And then the total price, so because of this duplication, what will happen? You will be having the space for this table will be very huge, correct? So this concept will called as denormalization. That means storing everything in a single table, okay? Storing everything in a single table, we call this concept as denormalization, okay? So now what will happen? Let us say if we split this into multiple tables, okay, meaning what? So just to reduce the data redundancy, let us assume we'll go here only. Okay, I have customers table. Okay, in the customers table, I have customer ID. Okay, and then customer name, and then customer location. Okay, customer mobile number, and then customer mobile number, customer email, and then customer address. Okay, so this is my customers table. Okay, or else let me open draw.io so it will be more clear. Okay, fine. So just let's try to understand. Okay, so here let us say I have the customers table. Okay, and here assume I have customer ID. Okay, and then here customer name, customer mobile, customer email. Okay, so similarly customer address. Okay, so this is one table. Okay, so and then I have products table. Product ID is the primary key, and then product name, product category, product expiry. Okay, so these are my product related information. Okay, so similarly, okay, similarly, I have here in the customers table itself, I have location. I have location ID, or else I'll say location. Okay. Now I have customers table, I have products table. Okay. And then assume I have created one more table called sales. Okay. Here I have sale ID. And here I have customer ID, product ID. Okay. Sale amount. Okay. Now let's try to connect these these three tables, right? So when you try to connect, so what will happen? So your Okay. So you need to understand how actually the data model will be designed, right? So guys, are you able to understand why we are doing all this stuff? So you need to understand the denormalization process first. So why we need a data model in a data warehouse? Okay. So the creation of a table structures with respect to a purpose, right? Business purpose. So that's what we'll call it as data model. Okay. So now in the data model creation process, so we have two uh, things. One is denormalization and normalization. Okay. So denormalization meaning storing everything in a single table, storing very large data in a single table with data redundancy, meaning data duplication. So if you see this particular table, if you see this particular table, the customer data will be duplicated multiple times if I buy multiple different products. Correct. So instead of that, if you keep if you keep your data model in a normalized form, if you keep your data model in a normalized form, your customer data will be created only once. Your customer data will be created only once. Similarly, whatever details that are required, or whatever the details we feel that data redundancy is going to happen here, so what we can do is we can place it in a table and then we can link it into different tables. So this process we'll call it as normalization. Okay. Denormalization and normalization. So storing data in a data warehouse is not that easy, guys. Okay. There will be a lot of design and modeling will be happen before we start our ETL. Be very clear. Okay. So we'll create tables as we like and we'll load data as we like. No, it won't happen. Okay. You should understand underneath the structure of it, right? You should understand why these many tables, why there will be a customer table, why will be products table, why sales table, different tables, why we have, why do we need to join again all these tables, can we maintain a single table? So you may be getting all these questions or queries, right? So the concept behind it is data modeling. Be very clear. In data modeling, storing data in a denormalized form and storing data in a normalized form is two different concepts, right? So you need to understand what are the impacts of denormalized form and what are the impacts of normalized form. Okay. So this normalized data model will be useful to reduce the data redundancy. Be very clear. Denormalized will use in big data world. Okay. So wherein we use this denormalized form in NoSQL databases majority of the times. Okay. So where actually that will help. But here in a structured RDBMS data warehousing systems, the major focus will be on the normalized form. Okay. So normalized meaning you'll be having multiple different tables, and as and when you required, you'll be joining all these tables, and then you will be loading your table. That's how it will be. Okay. Now, let us come to fact and dimensions. Okay, fact and dimensions. So, what is a fact table? So, in data warehousing, we have two different tables, two different types of tables. Okay, one is a fact table, another one is a dimension table. Okay, so what is a fact table and what is a dimension table? A dimension table is something which stores the dimensions of attributes, meaning, for example, a customer is there. Okay. If I want to store that customer information, then I'll create one table and then I'll place all my customer information into that table. Okay. Then if any kind of a transaction happened from the customer, then I'll create a transaction table. Then I'll store the transaction related measure, meaning the numerical value or the transaction value, in a fact table. Okay. That's how it works, guys. See, your account information is one dimension table, your customer information is one dimension table, but finally do a transaction, when you do a transaction, that will go to a fact table. Be very, very clear. Okay, here if you observe, customers table is a dimension table where actually we are storing the dimensions of this customer's object, right? Similarly, products table is a dimension table where we are actually storing the dimensions of your product object, correct? Similarly, when these two objects communicate each other, when they communicate with each other, and then they came to do a transaction, right? Right. So customer object came, and it is speaking to the product's object, and then it is buying a product. That's where the event is generating, and the transaction is getting stored in the sales table with reference to the customer ID and product ID, right? So the concept is very simple, guys. You need to just capture it. So dimension tables will store dimensions of the objects. Be very, very clear. These are actually descriptive information. Okay, these are descriptive information. And fact tables will store the measures, meaning the quantities, and then the sum aggregations, or the values, the totals, everything, the real values, it will store in the fact table. Okay, so your dimension tables will be loaded first. Be very, very clear. In the ETL process, you need to understand first and foremost layer that we will load is dimension layer. Dimension tables will be loaded first, and then your fact tables. Okay, and then your fact tables. Guys, are we clear? Am I confusing you? Any questions or queries? Come on, guys, open up.
Yes, clear, Venkat.
Prakati,
Yeah,
Sai,
okay.
any questions? Are we clear?
Yeah.
Yes, Venkat, clear.
Okay. Okay, fine. So let's proceed further then. So fine. Now we know what is the dimension table, what is the fact table. Okay, fine, understood. Now let us go a little bit deeper, right? So how actually we create a model out of it, right? So how actually we create a model out of it. Now in a typical business, your data modeler will understand the business attributes, okay, the business attributes that are required, and he will split those attributes in the form of tables. He will understand the business. Okay, so it's a banking business, so in the banking business there will be customer object, there will be account object, and then there will be employee object, right? And then similarly there will be location object. So that's how it will be, right? So your data modeler will understand the business, and then according to the business he will come up with a data model. In terms of data model, we'll be having two main data models, or schemas we'll call it as. Okay, two main schema. One is star schema, and the second one is snowflake schema. Okay, so one is star data model and the snowflake data model. So what are these models, right? The way that we store data, the way that we store data is called as a model, right? So let us understand what is a star schema, right? Let us understand what is a star schema. Here it's my location table. Sorry, it's not my location table. Let us say it's my orders table. And then it is some other table. So assume you have some different dimension tables, right? Customers, products, orders. What else we have? Just give me a minute, guys. Let me order items. Right. So here, if you see, just forget about this content. So these are all the dimension tables, right? So these are all the dimension tables. Okay. Now your data model, if you observe, it is forming a star, right? See here, your dimension tables surrounded by a fact table, right? A fact table surrounded by, a fact table surrounded by your dimension tables is called star schema. Okay, a fact table surrounded by different dimension tables is called star schema. Okay, and then a dimension table can also have different dimension tables, meaning assume here I have location, right? So location details. So here if you see, I have location name, state, city, country. Okay, assume this is my these are different columns I have, right? Now if I store this data in this customers table, what will happen, guys? For every location I'll be having n number of customers, correct? So from that location, if multiple customers are coming, this location information will be duplicated, isn't it? So that is where you actually create another table, another dimension table called location. You maintain location ID here, and then you keep all your location name, state, and then city. Okay, here what you'll maintain, you'll just maintain location ID. Okay, now what you'll do, you'll just try to link these two, right? So if a dimension table is surrounded by different dimension tables, then again it is called a snowflake schema. Okay, it is called a snowflake schema. So like that, let us say you have product name, product category. If your product category is having different attributes to store, and then each and every product category will be having multiple products, right? So in that case, if you want to, if you see that there is some redundancy data in products table, you can actually create a product category table and then link these two tables. So that is where your dimension tables are surrounded by different dimension tables, and again all the dimensions will be connected to a fact table. So that's where the snowflake, the extension of your dimension tables, right? So your snowflake schema will be having a little bit complex data model, and then your star is a straightforward thing wherein your fact table will be surrounded by dimensions. But in snowflake,
Even your dimensions will be surrounded by some other extended dimension tables. So that's the Snowflake schema. Okay, these are two different data models in real time projects we'll follow. Okay, in real time projects we'll follow. So in ETL process, there will be a different uh, analysis will be happening before building ETL pipelines. It is not that much simple to understand ETL. Okay, so you need to understand all these concepts before developing a ETL pipeline, right? So what are fact tables? What are dimension tables? What are dimensions? What are lower level dimension tables? So you need to load the lower level layer first. The intention is you need to load the lower dimension tables and then dimension tables and then fact tables. If you cannot directly load fact table in a data warehousing ETL concepts, be very, very clear. You cannot directly load a fact table because fact table holds all the primary keys from different dimension tables. If that primary key is not present in your dimension table, the reference won't happen. The foreign key and primary key relation, try to recollect, guys. Why we need to connect these tables? Because of this, we need to use the constraints called foreign key. Foreign key is a constraint which will connect all the tables. Be very, very clear. Okay, in one table, dimension table, if you see the if you have the primary key, that primary key will be the foreign key in your fact table. Okay, the primary key that is available in the dimension table will be the foreign key that has to be stored in the fact table. So by using this relationship, we can talk to any object at any time in the system. Okay, from the location object, I can actually talk to customer's object. The reason is the location ID is primary key in the location, but my location ID is the foreign key in the customers, so that I can link these two tables with this location ID. Are you with me, guys? Are you with me? Are you able to understand the concepts?
Yeah.
Okay. So similarly, I can talk to customer. I mean, customers objects can talk. Customer object can talk to sale object anytime, right? Because I have my customer ID, and the customer ID is the foreign key in the sales object, so that I can link these two tables by using the join condition on the customer ID. So when I say objects can talk, that means what? So we can utilize these two objects combinedly to derive some data outputs. That's the meaning. Okay, so be very, very clear on the concepts that we are going to we are going to solve, right? So here, if you understand these concepts, most of your data warehousing will be on these things only. Okay, so when you are building when you are building the data pipeline, or when you are developing a ETL pipeline, so the first and foremost thing that you need to ask your lead or ask your peers is, okay, so what is your source system? Okay, what is our source system, and what are our source tables? The first question. Okay, the second question, what is our target layer? Right, what is our target layer, meaning what is our target data store? Okay, hey, let us take an example. They asked you to build a ETL pipeline. So to build a ETL pipeline, what are the things that you need? You need to ask those questions. If you don't know these concepts, you won't be able to ask questions. Okay, so first and foremost question, so what are the source tables? Where is our source system? Your source system is SQL server, and this is the database, and these are the tables. Okay, so what is the loading strategy that you want me to apply? Okay, yeah, you can go for incremental merge. Okay, fine. What is our target data store? Snowflake is your target data store. Is there any ETL, or is there any existing framework that you guys are using, or do you want me to develop framework for it? No, we have a existing ETL tool called NiFi. You can use that NiFi tool and implement this pipeline. So this is how the discussion will go from a developer to lead, guys. Be very, very clear. Okay, when they assign you a task to build a data pipeline from source to target, right? So these are the questions that you need to ask. Once you got this information, then the immediate things that you need to ask is, okay, so I will build this pipeline for sure. Do you need any processing in the target layer, or do you want me to go for one-to-one mapping? Okay, meaning you want to place the table as is, or you want to add any columns by applying some logics on top of it, right? So these are the things that you need to get clarifications. Okay, and when you are connecting to SQL server, in the SQL server you will see these models. Be very, very clear, you don't see these models in your data lake systems, guys. Try to understand, you don't see these data models in your data lake systems. In data lake system, we hardly see these kind of data models. Okay, but in your source systems, which are OLAP systems, our job is to ingest data or to build pipelines from different OLAP systems, right? Or for that matter, different OLTP systems. So when you are connecting to those tables, when you are connecting to those tables, you will be seeing these kind of data models. You'll be seeing customers table, you'll be seeing products table, you'll be seeing some other table, some other table, some other table. So why these many tables? You'll get confused with all different hundreds of tables you will see in the production environment, right? So why do we need all these tables? So the concept behind this is this. Okay, fine. Now you have 100 different source tables. Okay, and those may be from OLTP or those may be from OLAP. It's secondary. Okay, and you got a task to build a data pipeline to ingest these tables into BigQuery. Okay, this is your first task. The first and foremost task is to ingest these tables into BigQuery. Now, you need to understand how actually you can build a data pipeline, robust data pipeline, and the loading strategies, implementing all these loading strategies, and understanding the schemas. Understanding the schemas is very important. You need to go and check your source tables first. The first thing that you need to do is you need to go and check your source tables first, and you need to check your data size. Check the record count in each table. Okay, so I have 1 million records, I have 2 million records. Okay, and then if it is a full load, you need to for sure you need to check the volume of the table. Okay, so these are all the things that you need to consider when you are working in a real-time project environment. Okay, so fine. So now we know what is a fact table, what is a dimension table, and what is a star schema, Snowflake schema. Okay, now we are good for with these concepts. Now let us quickly start the introduction to the BigQuery. Okay, so I think we have got good understanding on the data warehouse system. Okay, we have got good understanding on the data warehouse system. So I think we can start pretty well start the BigQuery. Okay, so the introduction to the BigQuery will see today, and tomorrow we will see the architecture of BigQuery. Okay, so tomorrow we'll see the architecture of BigQuery. So now let us understand what is BigQuery. In GCP, we have seen GCS, Google Cloud Storage, which is actually the object storage, right? And which can store huge volumes of data. That is one service that is provided by the Google. Similarly, in the Google Cloud Platform, BigQuery is also a service. Okay, BigQuery is also a service that fulfills, the scalable and serverless cloud data warehousing functionalities. Be very, very clear. A service in GCP, BigQuery is a service in GCP that enables scalable and serverless functionalities for a data warehouse. It's a cloud data warehousing system. BigQuery is a cloud data warehousing system with a lot of scalability and serverless capabilities. Okay. Now let us understand these two words now. What is scalability? What is serverless? Okay. What is scalability and what is serverless? Scalability we know in cloud computing introduction, we have seen what is scalability, right? So, and serverless, we need to understand this concept, serverless. So what do I mean by serverless? So let us take an example of an on-prem system. Okay, let us take an example of on-prem system. In the on-prem system, what will happen? You have a Oracle data warehouse. Okay, you have an Oracle data warehouse. In an Oracle data warehouse, what will happen? Database will be installed in a server. Okay, and database is a software, right? So Oracle is a software, so we just go and install that in a server, in a machine, right? In a machine. And in that machine, when you install Oracle, what will happen? It will occupy some space, and then it will work in that space. Your software will work in that space. Now, when your data volume is getting increased, what will happen? Your admin team has to take backup and remove data. Some kind of cleaning activities they have to do on a regular fashion. And this activities also you have to manage in on-prem systems. But in cloud, you don't need to worry about infrastructure. You don't need to worry about the compute and storage. Okay, your cloud provider will take that ownership. Okay, your cloud provider, it may be GCP or AWS or Azure, they will take the ownership of maintaining the infrastructure that is needed for your development, or that is needed for your application. That is called serverless. Okay, it doesn't mean that there is no server. Okay, there is server, but the maintenance of that server will be taken care by the cloud provider. You don't need to worry about in on-prem systems. DBS will take care. Okay, in on-prem systems, DBS will take care of all our issues, all our compute issues, or any storage issues or memory issues. DBS will be taking care in on-prem systems, but here cloud providers will take care. So that's where they introduced a term called serverless. Okay, serverless service. So typically in the background for BigQuery, or for that matter any data warehousing system, we need two things, guys. One is storage, another one is compute power. Okay, storage meaning the hard disk, you can say. Okay, storage meaning in terms of our local terminology, storage meaning our hard disk or SSD. Okay, compute power meaning our processor, right? Intel Core i3 or in i7, i5, AMD. So these are processors that we'll use in our machines, right? Similarly, here we call it as a compute power. Okay, processing power. Okay, we need storage to store our data, and we need compute power to process our data. Two things we need in a typical data warehousing system from the infrastructure standpoint. Okay, from the infrastructure standpoint, if cloud provider is maintaining these two things, then we call it as a serverless. If cloud provider will, if cloud provider is giving that to our flexibility, then we have to manage it, or we have to go with our flexibility. So in Dataproc, we have that flexibility of selecting the infrastructure, what infrastructure we need. But in BigQuery, we don't have that feasibility. BigQuery is a complete serverless. Okay, you can run your query. It will scale automatically. It will go parallel in the background. Okay, you don't need to worry about any kind of infrastructure in the background. What kind of a machine it is using? What is the CPU? What is the storage? You don't need to worry all those things. You don't need to worry about all those things. So your Google Cloud platform will take care of it. Okay, that's why I call it as a serverless. Okay, and scalable, it is distributed, it can scale automatically in the background. Okay, for example, you are querying a 1 terabyte table and you applied a query on top of it, then it, depending on your query execution plan, your big query is scalable in the background. It can scale automatically in a distributed fashion, and then it will give the results very fast to you. Okay, so that is what scalable and serverless meaning. Okay, so end of the day, BigQuery is a data warehousing tool, cloud data warehousing tool inside the Google Cloud Platform. Okay, so let us see some competitors for BigQuery service, right? So in outside platforms, you'll see Snowflake, right? Snowflake is a technology or a cloud data warehousing system, right? So that is also a competitor for BigQuery. In AWS, you'll see a service called Redshift. Okay, that is also a competitor for BigQuery. Redshift is also a structured cloud scalable data warehousing system. Okay, similarly, in Azure, we have a service called Synapse. Synapse is a cloud data warehousing system from Azure, right? So these are all cloud data warehouses that we have available, popular cloud data warehouses, right? So you need to understand, inside the cloud, we are getting a data warehousing kind of a functionality for big data workloads. Be very, very clear, for big data workloads. Okay, inside the cloud platform with the cloud features, the scalability, the elasticity, right? The disaster recovery things, or the replication things, or whatever it is, all the cloud functionality features, right? Cloud computing features. So all these features will be there in your services, all these services. The BigQuery, if you take Dataproc, if you take the cloud, meaning is that only, right? So in GCP you are using all these services, so the all these services will come with your cloud computing features, the scalability part, the elasticity, the fault tolerance, everything you will get. So now let us understand some key features of BigQuery, right? So see here, you can actually use BigQuery for real-time streaming, data ingestion, and batch processing. Okay, for both batch and real time. Okay, so what do I mean by batch and real time? Okay, now yesterday we have seen incremental load, right? Yesterday we have seen incremental load. What is incremental load? It's a batch processing, meaning you are going to the source system and you are pulling the data in a batch fashion, right? So for every day 11 p.m., every day 11 p.m., your pipeline got scheduled and it is going to the source system. It is asking data between the time range, correct? And that is one batch, correct? That is one batch, and it is getting loaded into target system. And the next day it will again go to the source system. It will ask data between one time range. That is another batch, right? So batch by batch we are processing. That's called batch processing. Okay, now let us assume, as and when the record comes into the source system, immediately that should be reflected in the target system. As and when the record comes into the source system, immediately that should reflect into the target system. That is what real time streaming. So streaming is very, very complicated and complex to implement, and it is the cost consuming service, I can say. Streaming, real time streaming is, that is, you may be seeing, right? You'll be doing the transactions and somebody in the room and sitting, the overall view, how many customers visited, or how much sale happened. So they will be looking at one dashboard and seeing it, right? You may be seeing it in restaurants, right? So in restaurants, as and when the customer visited and ordered and then did the transaction, the restaurant owner will be sitting in the room and then he'll be looking at the dashboard, right? So as and when you complete the transaction, immediately the dashboard will be reflecting with the data, right? That is what real time streaming. right? So if you want to implement a streaming pipeline, we need to analyze, or we need to know the streaming services like PubSub in Google Cloud, and if it is a on-prem, we have a Kafka service, right? So that's what streaming means. So streaming and batch processing both can be supported by the BigQuery cloud data warehouse. Okay, and then AIML support, the first and foremost data warehousing system which got the AIML support, right? You can implement machine learning also in BigQuery. BigQuery has that inbuilt inbuilt functions, machine learning functions you can utilize in your SQL itself, okay, in your SQL itself. So SQL compliant BigQuery supports SQL, guys. You can simply write SQL queries in BigQuery, okay, and it also have the machine learning functions, which where you can actually write BigQuery ML queries also. Okay, so that is the biggest advantage in BigQuery. You can use BigQuery for storing data in the form of tables, and you can also use BigQuery for processing your data. Okay, so and then it is a fully managed serverless, as I've already discussed. It is fully managed by Google Cloud Platform. It's a Google's proprietary technology and service. Okay, so it will be completely managed by the Google Cloud. Okay, so the serverless capabilities, the infrastructure part of it, will be completely managed by the Google Cloud. Okay, and then automated data transfer service. So in BigQuery, you have a functionality called data transfer service. Okay, you can ingest data from outside of your cloud platform to your BigQuery by using this service, data transfer service. Okay, and then it is highly scalable, as I have already told you. So depending on your query execution plan, your BigQuery compute can scale. Okay, your BigQuery can scale automatically depending on your query plan. Okay, and access control features. So it has IAM access control. So identity access management rules are there in BigQuery. So typically there will be a very good security and access control provided by the Google Cloud Platform. Okay, and federated queries and API integration. So these are the two important features, guys. So most of the times data warehousing systems will lag in federated queries. So federated queries meaning, let me give you one example. Okay, I have a big query in my GCP Google Cloud Platform, and similarly I have Cloud SQL. Okay, that is one more database in Google Cloud Platform. And similarly, I have Cloud Spanner, that is a RDBMS service in Google Cloud, and I have Bigtable, okay, or else some other database. So in from BigQuery, I can query all these tables. I mean, not only BigQuery tables. You can query Cloud SQL tables. You can query Cloud Spanner tables from BigQuery. So meaning the storage will be from the Cloud Spanner, but the compute will be from the BigQuery. Meaning you don't need to transfer data between the services. You can apply a query from one service to another service. That's what the federated queries. If your data is scattered in multiple places and querying from a single place, right? That is what a federated query we call it as. Okay, so most of the data warehousing systems will lag in this federated queries. Okay, the data should be present in that place only, then only we can query. But in BigQuery or in Google Cloud Platform, we have this feature of querying data from multiple places, uh, right, into single place. So that is what federated query is. Okay, so that will be supported by the BigQuery. That is a very good feature. And API integration, you can write APIs. BigQuery will support a lot many programming languages, guys. You can connect to BigQuery and do things using Python. You can connect to BigQuery and do things in C++, Java. Any kind of a programming language integration is possible in BigQuery. Okay, so that is also one of the greatest features. Okay, it is serverless, scalable, and it supports ML. And then it has federated query support and it supports API integration. So these are the key features of your BigQuery cloud data warehousing system, guys. Okay, and if you see the streaming power of BigQuery is 100K rows per second, right? So it's not a small data, right? 100K rows means assume you have 1 lakh records per second it will support, right? And if it is a batch, right, 1 TB per second, 1 terabyte data per second, it will support the loading and the ingest capabilities of BigQuery. Try to understand, right? So there is in real time you don't see that, small tables, customers table, orders table, you don't see, guys. Be very clear. In real time you will see tables of size terabytes. Okay, so that's where the big data world comes, right? So you need to think in that manner. Okay, any questions about the introduction to BigQuery? Any questions or any confusions? Come on, guys, ask if you have any confusions or queries. From tomorrow, we'll go a little bit deeper into the BigQuery. We'll discuss more concepts that are there in the BigQuery. We'll start with the tables, storage, compute, all these things. Architecture, we'll see how it will work internally. We'll see everything. We'll see. Okay, but for now, try to understand the basic ground level concepts. Okay. Any questions, queries? Open for questions, guys. Come on, speak out. Are we clear?
Yeah. That's fine.
Okay. Sai, are you able to understand? Sai, are you there? Okay, fine, guys. So I hope you have gained some understanding on BigQuery and data warehousing concepts. Yesterday's and today's session, right? So, what is a data warehouse? Why we need a data warehouse? And some data warehousing concepts we have seen. These are very simple concepts in data warehousing that we majorly use. So those things only I focused. And there is a lot about data warehousing, so but we don't need all those things at this moment. So we have seen the basics of data warehousing and the important concepts in data warehousing, and we have seen the introduction to the BigQuery today. So tomorrow we will focus on the architecture of BigQuery, and we will see the BigQuery user interface in Google Cloud Platform. So how the BigQuery, how to open the BigQuery service, right? So how to create tables, how to query tables, we'll see after the architecture. Okay. So that's all I have for today, guys. So thank you so much for joining once again tomorrow.
Yeah. Thank you.